from each other. The t-test also tells you how significant the differences are. In other words, it lets you know if those differences could have happened by chance. So what is t-score? The t-score is a ratio between the difference between two groups and the difference between the groups. The larger the t-score, the more difference there is between groups. The smaller the t-score, the more similarity there is between groups. When you run a test, the bigger the t-value, the more likely that it has results that are repeatable. Number 1, a large t-score tells you that the groups are different. Number 2, a small t-score tells you that the groups are similar. When to use a t-test? A t-test is used when the sample size is smaller than or equal to 13. By using the t-test, it provides more accurate data than by using t-test. Always remember that the t-tests are used when the sample size is below or equal to 13. So let's have 3 examples.
According to Department of Education, high school teachers work an average of 40 hours per week during the school year. A district supervisor of a certain school surveyed 28 randomly selected teachers and found that they work an average of 42.6 hours a week, and the standard deviation was 3.75 hours. Test if the mean number of hours worked by teachers in the supervisor's school district differs from the national average. Use alpha 0.01. Number 1, given. Mean is equals to 40 hours, S is equals to 3.75 hours, X bar is equals to 42.6 hours, and N is equals to 28. Step 1 is to define the hypothesis. HO is equals to mean is equals to 40, and HA is equals to mean is not equal to 40. Step 2 is to state the alpha. The alpha is equals to 0.01. And it is two-tailed test. And the DF is 27. Step 3 is to find the critical Z value. Z is equals to positive negative 2.771. Step 4 is calculation. Z is equals to X bar minus M over S over square root of N. Z is equals to 42.6 minus 40 over 3.75 over square root of 28. Z is equals to 3.67. Step 5 is to plot the graph. Since the problem is two-tailed test, you will shade both positive and negative 2.771 on the end sides of the graph. And then plot positive 3.67, and we will reject HO. Step 6 is the conclusion. Since we accept HA, the mean number of hours worked by teachers in the supervised school district differs from the national average. Problem number 2. In a population, the average IQ is 100. A team of scientists want to test a new medication to see if it has either a positive or negative effect on the intelligence, or no effect at all. A sample of 30 participants who have taken medication has a mean of 140 with a standard deviation of 20. Did the medication affect intelligence? Use alpha 0.05. Number 2 given. Mean is equals to 100, sample is equals to 20, X bar is equals to 118, and N is equals to 26. Step 1 is to define the hypothesis. The HO is mean is equals to 100, and HA is mean is not equal to 100. Step 2 is to state the alpha. The alpha is 0.01. And it is a two-tailed test. And the DF is 25. Step 3 is to find the critical Z value. The Z value is positive negative 2.060. Step 4 is the calculation. Z is equals to x bar minus mean over S over square root of n. Z is equals to 118 minus 100 over 20 over square root of 28. And the Z is 4.59. Step 5 is to plot the graph. Since it is a two-tailed test, we will plot the each end of the graph and shade it. And we will plot positive 4.59. And we will reject HO. Step number 6 is the conclusion. Since we accept HA, the medication did affect intelligence. And that's the final answer. Problem number 3. The mean serum level measured in 12 patients for 24 hours after they received a newly recommended antibiotic was 1.2 milligrams per deciliter with a standard deviation of 0.4 milligrams per deciliter. If the serum level in the general population is 1.0 milligrams per deciliter, test whether or not the mean serum level in the sample group is significantly different from the general population. Use alpha 0.05. Number 3 given. Mean is equals to 1.0 milligrams per deciliter. S is equals to 0.4 milligrams per deciliter. X bar is equals to 1.2 milligrams per deciliter. And N is equals to 12. Step 1 is to define the hypothesis. HO is mean is equals to 1.0 milligrams per deciliter. And HA is mean is not equal to 1.0 milligrams per deciliter. Step 2 is to state the alpha. The alpha is equals to 0.05 and it is a two-tailed test. And the DF is 11. Step 3 is to define the critical Z value. Z is equals to positive negative 1.90. Step number 4 is the calculation. Z is equals to x bar minus mean over S over square root of n. Z is equals to 1.2 minus 1.0 over 0.04 over square root of 12. Step number 5 is to plot the graph. Since the graph is two-tailed, you will both shade the ends of the graph. And then plot 1.73 on the positive side. And we will reject HA. Step number 6 is the conclusion. Since we accept HO, the mean serum level in the sample group is not significantly different from the general population. And that's the final answer.
What you need to learn about t-test. Always remember, t-test provides more accurate data than the t-test. And always remember, t-test is only used if the n is less than or equal to 30.